Say hello, Winston. Say hello, Piper. No, the wind is more interesting. I get you. Hey guys, it's Fowler for your next daily dose of a math 2 honors. So, we've been kind of working towards doing proofs, and proofs can kind of be a little bit tricky because it's basically the baby steps. You gotta say what you know and why and how it proves it. But before we do those proofs, maybe we'll do those Mondays, I don't know, or Tuesday. I might space it out a lot because it is kind of difficult and different concept to think about. We're gonna look at these 5 postulates because, well, 5 postulates that prove triangles congruence, because we don't wanna have to go through every little piece of information and say, this angle's congruent to that angle, this one's congruent to this one, this one's congruent to this one, this side's congruent to that side, this side's congruent to that side, and this side's congruent to that side, because that would be so much work. So for all of our postulates, we only have to know 3 pieces of information about our triangles. It's either gonna be sides congruent, angles congruent, or a mix of both. Okay, and so I'm gonna do it on a sheet of paper today. I'm not gonna give you guys a note on this one. We're gonna see how it goes, and maybe we'll continue like that. So you guys will want a sheet of paper, a pencil, and I don't think we need a calculator today. Okay, let me make sure I have my stuff ready in front of me. Sorry. And flip. So I want you guys to draw 2 congruent triangles, and I'm gonna write a little heading on the top of this. Triangle, congruent, postulate. Postulate is just a fancy way of saying it's like a proof or a theorem, but it's not quite there. There's nothing that could prove it wrong, but there's nothing that can totally prove it right. Postulate, we use them in proofs. So I think we've done, what postulate have we done already? I don't know. I'll come up with an example and I'll comment on here. I can't think of it at the moment. So triangle congruent postulates. Okay, so to say 2 figures are congruent, we'd need to know every angle is congruent to its corresponding and every side is congruent to its corresponding. So we would need 6 pieces of information. To say that 2 triangles are congruent. Okay, so if I draw my little triangles here, we would need to know that this angle is congruent to that one. Those 2 are congruent. Those 2 are congruent. And the sides we'd also have to know. And we'd have to know the reason behind them to say they're congruent as well. Because I don't know about you, but I like to question some things, and it's not like the blind leading the blind here. So to say these are congruent, we would have to know each piece of information matches the corresponding one. But I know a lot of people are lazy, and we don't want to do that because that would just take too much time and too much effort just to say the triangle ABC is congruent to triangle EFG. So it has been proven that we can use 5 different methods to prove triangles congruence. Okay, so our 5 postulates. That have enough info, that are enough, that give enough info. To prove congruence. Okay, so the first one, all right, is that if we know all sides are congruent. Okay, if we know that all three corresponding sides are congruent, that is enough information to say our triangles are congruent. So if I draw two triangles, and let's call this one CAT and DOG. If we know we have corresponding sides that are all matching up, so this is same length, that's same length, and that's same length, then we can say they're congruent by side, side, side. Okay, but we'd have to know all three pairs of sides. So triangle, CAT, is congruent to triangle, DOG, by our side, side, side. Okay, the sides would all form the same type of angles, okay? And that makes this one true. Our second one is if we have side, angle, side. Okay, so it's always two sides, two corresponding sides, and the angle between them. Okay, the angle always has to be between them. That's why the A is in the middle. It connects the two sides together. Okay. So let's go. X, Y, Z, and W. So if I knew this side was congruent to that side, and this angle is congruent to that angle, and since they share this side, we can say that's congruent as well. Okay, so we've got two sides and the angle between them on that one, two sides and the angle between them on this triangle. So I can say these two triangles are congruent by side, angle, side. Okay, and now when we name this one, I always like to circle one thing and go through the one and through the two. So I'll say triangle XYW. And I want to do the same thing on the other side so my statement is true. So X is over here. It has one tick and no ticks. So this angle that matches to him would be Z because it has one tick and no ticks. So Z, X goes through the one tick, down the two, through the one tick, down the two. So it should be Z, Y, W when we name it, okay? Because the angles and sides have to match up, our statement has to be made that way, okay? And this one, they are congruent by side, angle, side. So that's postulate number 2. Number 3 is angle, side, angle. So this one has two angles and the side that connects them, two corresponding angles. And when I say things like that, I mean like corresponding angle pairs. This one, two corresponding angles or sides, pairs. So like that's a pair, and then this one is a pair. And the side between. Okay, the side connects them. So let's see. I'm gonna draw my two triangles like this. And let's go L, M, N, O, P. So here's triangle 1, here's triangle 2. we want two angles and a side between them. So if I had this angle here and this one given to me, and I had this side and this side given to me, and that information alone is going to give us enough to prove these congruent. Because what do we know about these two angles here? Well, yeah, they're vertical angles, so we can mark them congruent. Okay, vertical angles are like a little hidden one. Just like this side congruent to itself is a hidden one. So now we've got two angles, if I cover it up, and a side between them. Okay, two angles and the side between them. So that is enough information to prove these two triangles congruent. So let's go triangle LMN. Okay, so if I start with L and go through there and go through there. L has no angle marking on it and no ticks on each side. So he's going to match up to P because it has no angle marking and no ticks. So triangle P. Okay, P goes to the one arc and then to the two arc. So it should be P, O, N. And this is by angle, side, angle. So there's our 3 postulates so far. We've got 2 more, and then some fake news. I'm gonna go ahead and flip this over. You can pause here if you wanna get this copied down. 3, 2, 1, beep. Okay, on the back, we're gonna do our number 4 postulates. This one is angle, angle, side. Okay, so that means we've got 2 angles and one side that does not connect them. Okay, so 2 corresponding angle pairs and one side pair not between them. So I'm going to go ahead and draw my triangles. And let's go L, K, F, and T. Well, that's a J. Okay, so this one has 2 angles, so I'm going to label that's given to me L and F are congruent, and this angle K, that's LKJ, I'm going to mark congruent to FJK. Okay, so we've got 2 angles so far. Is there any hidden congruent parts here? When I say hidden, it's like vertical angles, alternate interior angles, alternate exterior angles, corresponding angles, a midpoint, or a reflexive property, which means a shared side. Yep, they share this side right here. So I'm going to mark that side congruent, okay, because it's shared. Shared side, it's a hidden congruent part. Okay? So we've got 2 angles. The side is not between them, so we've got angle, angle, side. So I can write a statement, triangle, LKJ is congruent to triangle. Let's see, L is this one, which matches F. So F, if I go to K, that goes to 2, and then J through the 1 tick. So F, go to the 2, so that's J, and then down to K by angle, angle, side. Okay, The last one is going to be hypotenuse leg. Okay, when we hear the word hypotenuse, we're automatically thinking about what kind of triangle? Yep, right triangles. Okay, so hypotenuse leg, or HL, means that we know the hypotenuse and another side correspond. Okay, so hypotenuse is always across from our right angle. So if we know the hypotenuse is congruent and we know one more side, we can say these two triangles are congruent by that. So let's go. Okay, so I can name my first triangle AES is congruent. See, A starts here, it goes through here and then up there. A has no angle marks and it's by the one tick and none. So one tick and none gives us R. And it goes to the right angle first and up. So RCT by HL. Okay, now fake news. Or false. False postulates. Okay, so out of these alphabet soups are ones that work, are side, 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 angle, side, angle, side, angle, 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 side, and HL. Now there are a couple combinations of sides and angles that do not work. No. So let's look here. One with all A's. Okay. No. I can't spell anonymous. No Alcoholics Anonymous. Okay, no AAA. Because I can have a triangle where the sides are congruent like this equilateral. So the angles are all congruent like this equilateral. And I can also have a triangle that's been dilated, and so all its angles are congruent as well. Okay, but they're not the same shape or same size. So that is a dilation or a similar figure, not congruent. So AAA does not work. The last one, combination of A's and S's, if you can spell a bad word, you know, this backwards or forwards or anything like this, no buts in geometry. It does not work. Okay, again, if you could spell a bad word, it does not work. And I will show you why. Okay, if we look here at the top, so we've got the first triangle has 6, 11, and a 30-degree angle. Angle, side, side, bad word. Looking here, angle, side, side could make this triangle. Oop, foul or fail. There we go. It could make this triangle right here, okay, which is not the same. Or it can make that one, which is the same. So we don't know which one is exactly. So we cannot say it's congruent by side, side, angle. And the other one, again, shows you the similar figures of angle, angle, angle. So no buts in geometry, spell bad word. There is not enough info for either of these. If you get those little acronyms. So I'm gonna do a couple examples with you, just so you can kind of see. Let's go ahead and look at this one right here. Okay. So we've got this triangle and this triangle. We've got one angle marked here and another angle marked here. So we definitely have two A's. Okay. And I'm not going to mark it on the other triangle because I just don't want to confuse myself. Now, we want to look for any hidden parts. So, do they have vertical angles? Do they share a side? Or do we have some angles formed by parallel lines? For this one, they share that middle side. So I'm going to mark the side in. So we have a side somewhere. Is our side between the A's or not? Does it connect our angles? Yes, it does. So this one should be angle, side, angle. Okay, let's look at the one below it. All right, we've got an angle here. We've got an angle there and a side. Same over here, angle, angle, and a side. So we've got two angles. Does the side connect them? Nope. So it's just angle, angle, side, which is one of our theorems because it doesn't spell a bad word and it doesn't give you Alcoholics Anonymous association. All right, number 5, the next one. We've got a side here. We've got a side here. Okay, any other hidden parts? Vertical angles, reflexive side shared, parallel lines. Well, there is a vertical angle here. So two sides is the angle connecting them. Nope. It's not. Look at that. That is a bad word backwards. That's not allowed. So for this one, not enough info. Okay, and let's look at this one right here. So that triangle mark there means this is parallel to that line. So if we're having parallel lines, we want to see what line intersects both of them. Well, this one right here, because that's transversal. So we've got this angle here and this one here that correspond on the triangles. So we've got an angle, we've got another angle, and a side. So two angles. Is the side between them or not? Well, it definitely connects them. So this one should be angle, side, angle. Okay, and then let's look at, what's another good one? Aha, this one. Okay, so we've got a right angle on both these triangles. We've got another side and another side. So two sides and an angle that does not connect them spells a bad word, doesn't it? Which is not allowed. But we have a right triangle, right? Which postulate deals specifically with right triangles? HL. So for this one, do we have the hypotenuse? Well, that's a cross. This is the H. Do we have another side? That's the L. So this one can be proved by HL. It can also be proved by another one because we have vertical angles. Okay, so this one could be angle, angle, side as well. So either of those are correct. And let's go to the one right below it. So we've got this angle marked here. So So that's one angle. We have a reflexive side. Is there any other information marked congruent besides that? Nothing marked, okay. Our hidden figures, do we have vertical angles anywhere? No. Do we have parallel lines? No. We already got they shared a side, so all we have is a side and an angle. Is that enough information to prove they're congruent? Nope, so not enough info. Okay, so 5 postulates: side, 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 angle, angle, side, angle, and hypotenuse leg. The fake ones, the ones that do not work. If you spell a bad word, ASS, that is not okay. We do not swear in my room. And AAA, okay? You guys are gonna have a couple IXLs on this. There's actually 3, and you only have to get to an 80, but it's going through the ones postulates, like there's only 2 postulates per one. So if we just take a peek at this one right here, it says which 2 triangles are congruent by side, side, side theorem. So it's telling you which theorem to use. And then it wants you to write a congruency statement. So you want to find the ones that have the same marking in the same order, okay? So if we look here, and I start with this long side, we've got 1, 2, 3. Okay, this one has 1, 2, 4. Okay, so these 2 definitely do not match. This one has 1, 2, 3. Okay, so these 2 have the same exact markings. So I can name the first triangle however I want. You do not have to capitalize it. So I'm just gonna write H-I-G. H to I to G. So H starts here at 1 and 2 ticks. On this one, the 1 and 2 ticks is T. So T would need to come first. Okay, so H to I follows the 1, so T, R, S. And I'll hit submit. See, good work. All right, this one wants to know by side angle side theorem. So it has to have the same markings in the same order. So let's see, 1 tick, 1 arc, 2 tick. 1 tick, 1 arc, 2 tick. 1 tick, 2 tick, 1 arc. Okay, this guy is the oddball because these 2 both have the angle connecting our sides. These sides are not connected by the angle, so he is gone. So name the first triangle however you want. I'm gonna go UVW. Okay, and my second one just has to match. So U is by 0 ticks and 1 tick. So 0 ticks and 1 ticks would be J. So J needs to come first. And then U followed the 1 and then the 2. J followed the 1, so I and K. And submit. Okay, they're all like that. The other 2 ones are just like that, just with other postulates. So you're going to be responsible for doing those 3 today, or actually this weekend, because I probably won't check it today. Just saying, you got some time. But try your best. Please let me know if you have any questions, because this is difficult and it's a different way of thinking. All right, guys, have a great weekend and see you on Monday. Pipe says bye.